lesson 9.4 times 2. Homework 2 to 26 all, and start working on the study guide. We're going to be working with extracting roots from the radicals. Example over there with your square root of 8. We're going to take our radicals and rewrite them with fraction powers, and our fraction powers and rewrite them with radicals. So here we go. We need to know these rules. So for the rules for the product of powers, I don't care about the name. I need to know that you know the rules. So again, when we had a like base here, it was important that it was a like base. What did I do with the exponents? I added them. Good. So now I need you guys to finish up everything you can figure out from the rules while I type in attendance. Okay? So finish filling this in. We'll pull it back together, and then we'll keep going from there. But you need to know these rules. So go. Help each other. Okay, I'm going to pull you guys back together. So for the quotient of powers, you saw like base division. What did you tell your friend to do? Subtract. Good. Okay, next. Power to a power. All we had to do was what? Multiply the exponents. Okay, now the next two go together. The first one, the parentheses, is attached by multiplication, thus the word product. The second one is attached by division, thus the word quotient. Okay? And you see the exponent on the outside. What are you doing with the exponent on the outside? Yeah. So they write it in more words, but that's all you're doing is you're distributing the exponents together. Question. Okay. Everybody should know this one. You just have to memorize it. Anything to the 0 power is 1. Okay, good old negative exponents. A negative power means take the reciprocal, okay? And when you take the reciprocal, you change the sign. So when the sign was negative, you change it to a positive. So thus, that's what both of these say. You're going to take the reciprocal and switch the sign. So if the negative a to the negative m, I flipped it, reciprocal, 1 over a to the m. On this one, do you see the negative m is in the denominator? So when I flip it, a to the m is going to be in the numerator, and then the sign becomes positive. So these are all our Algebra 1 rules that we're going to be using over and over again in addition to something else I'm going to show you. Questions? Okay. So please look those over besides all your perfect squares and cubes, etc., so that when we start using everything, you are amazing at it. And by the way, while people are finishing writing, I haven't been able to figure out how to pull up the detailed report yet, but Ms. Hill came over to tell us that East Lake beat all the other schools in the county on the exam. That means including the ones with the IBs and the fundamentals, where if you're not if you don't do what you're supposed to, they kick you out, and the tech schools and all that stuff. So good job. Pat yourself on the back. Except if you didn't do well. But a lot of you did really well. Okay. Anybody still writing this down? Do it when I'm done recording so I can move out of the way. Okay, just remind me before I shut down. Good? Okay. Okay, so this is your notes. This is already in your textbook. I'm going to rewrite it for you so you can see it step by step. After I do this and 2 others, I want you to be able to come up with your own rules so we don't have to do all this work to do the conversion. What this is going to do for us is convert a square root into a fractional power. So I know that the square root of x is equal to x to what fraction power. And then we're going to build so that even if there's an exponent with the variable, what to do. So I'm going to rewrite just like what they have, but so you can follow it with me step by step. And because it's already done for you in the textbook, all you have to do is watch. Okay? So it says that I want to solve this. Square root of x equals x to the a, and I want to solve for a. Okay, so step 1, if I want to get to the a, what do you think you want to get rid of first? How do you get rid of a square root? Square it. So we're going to square both sides. Okay, so square root and square cancel. Do you agree? X to what power? What's taken for granted there? How about a 1? Yes? Okay. Still with me? Okay, here comes the next rule that's really important. Are your ears open? Like base x, like base anything, set your exponents equal. If the bases are the same, or the base is the same, set the exponents equal. So 1 equals 2a, so now I can solve for a, and a is 1/2. So what I just proved to you algebraically is the square root of x is the same thing as x to the 1/2 power. So as the values get meatier, if you freaked out during a test and you couldn't just see your shortcut, you could always solve it algebraically. Now, this one came with a restricted domain. It said x has to be bigger than or equal to 0. Anybody know why? Why did this problem have a restricted domain? You know this. Why did it have a restricted domain? Because you can't square root a negative. So it goes in where, remember when you have a square root, a 4th root, a 6th root, an 8th root, etc., that your x had to be greater than or equal to 0? That's what that is. Question on this? Okay. Now, let's take a look at this one. This is now working with the cube root. So let's do the same idea. I'm going to start with cube root of x equals x to the a. What would I do first? What would you do to both sides? Trying to get to the a. Cube it. Good. So we have x equals, x to the 1 equals x to the 3a. Here comes that new important rule. What am I going to do? Thank you. Set the exponents equal. So a is 1/3, yes? So this is confirming that the cube root of x is the same thing as x to the 1/3 power. Are you still with me? Okay? Because you have to be able to do that conversion. So I'm hoping you're thinking through, well, I can make my own little shortcut. I'm not going to do all that work. Okay, here comes another one. This time it's the cube root of x squared equals x to the a. Again, I want to write this in, I want to find out what the fraction power is for this, the cube root of x squared. So step 1, how do you get rid of a cube root? Cube it still, okay? Okay, next thought. Important. Say it louder, I'm old, I can't hear. Set the exponents equal, okay? And then solve for a. Okay, let's see what we get. A is 2/3. So then we said the cube root of x squared is the same thing as x to the 2/3 power. So I want you to look at that. Could you come up with your own rule so that we didn't have to do all that math and I could just do the conversion in my head? Okay, so Lindsay, tell me what you're thinking.
So the exponent inside the radical is the greater fraction, and the exponent outside the radical is the fraction.
Perfect. Okay, so the square, the exponent inside the radical, was the numerator, and this guy right here, and it's a new word for most of you guys, even though they used to teach it in algebra, is called an index. So the index is going to be the denominator of your exponent. And that's it. It is truly that easy. Okay? And then you don't have to do all that work, but you could if you freaked out. Okay? So you have a backup plan. So what I would like to do real quick is just fill this in without having to do any work. So the first 2 rows are done for you. And we'll come back and do the restrictions afterwards. I want to do the second 2 rows. So they gave me x to the 2/5, and they want me to rewrite x to the 2/5 in radical form. X to the 2/5 in radical form. So I need to figure out where to put what? Perfect. Got it. Perfect. The 5 is the index, so it's read as the 5th root of x squared. And you can write it like that or like this. They're both the same thing. And the reason the resource uses the parentheses as well is so that they can show you there's more than one way to write the same thing. Okay? Now let's do the last one. Somebody else brave. This is the 5th root of x. What are you thinking? 5th root of x. We want to write it as a fraction power. You've got it. It is x to the 1/5. Okay, now let's go back and talk restrictions. Do you notice that when this guy here was even, the 4th root, the restriction was x was greater than or equal to 0. But when we had the 5th root, it was all real numbers. So it goes back to rules from 2 days ago. So for this 5th root of x, tell me about my restriction. All real numbers. You've got it. And then the 4th root of the x cubed, what does x have to be? Greater than or equal to 0. Question for me.
So I have to do like with the negatives, so if it's an odd number of negatives, just to
Wait, slow.
an odd number, is that so like the negatives, when they repeat out that many times, will still be negatives, so it can still like.
On the 5th root, is that what you're talking about? Yeah, these have no restrictions because all you have to do is visualize that it goes to the right and left forever, no matter where you put it. It's still going to be continuous to the right and left forever. That's why it's always all real numbers. There's no stopping point on it. Question. Okay, moving on. Okay, so now, yes, ma'am. I can, or I can take a volunteer. Anybody brave want to talk about? So the question on the floor is, how do you know whether your restriction is all real numbers versus x was greater than or equal to 0? What did you see that told you one from the other? Anybody? Go ahead. Okay, so the square root versus the cubic. So when the index here was a 4, even, but this was even, this has to be x is greater than or equal to 0. Even. So if this is a 2, see where I'm pointing with the index. This is a 2, 4, 6, 8, 10, 12, 100. Then it has to be x is greater than or equal to 0. And then 5th root, 7th root, 9th root, 13th root, it's going to be all real numbers because all those guys look like this and they go continuously forever and ever. Good? Okay. Okay, so now we want to take this problem and they work it through for you 2 ways. And of course, I'm going to work it through for you on my own. And I tend to work these through in less steps, but that's totally up to you. You know how much work you need. What's neat about this is they're showing you that you can work this through in radical form or exponential form and still get the same answer. Please always read the directions. Usually the directions will tell you if they want the final answer in radical form or with a rational exponent. Okay? So make sure you answer correctly. The biggest mistakes I would see on a test is they wanted the answer in radical form and somebody gave me a fraction power instead, or vice versa. Okay, so we're going to start with this. Cube root of, and all I'm doing is breaking it apart. And on my paper, I wouldn't even do this. This is just me thinking. This is how easy this problem is going to be for you in a sec. Now, before I started the recording, did we talk about the cube root of 8? What did we say the cube root of 8 was that we learned in geometry? 2 square roots of 2. We said 8 was 4 times 2. Cube root, oh, we didn't even do this one. That was a different one with square root. So this is even easier. Cube root of 8 is 2, and we're done. So sorry. I was thinking it said square root. Some of you were answering as if it did say that. Okay, so I've got plain old 2. Now here comes the variable part. Cube root of x to the 6. Isn't cube root like a 1/3 power? Where's the 3 in the 1/3 power? In the denominator? Isn't that like division? So that's what we're going to do. We're going to put this 3 into this 6. Does 3 go into 6? How many times? Good. Done. Okay? So if you can think this with the problem, it's really just one step. They gave you the problem, I wrote the answer. If you wanted to write it as a fraction power, so they said it's equivalent to the 1/3 power, so I'm going to take the 1/3 power and put it with both parts. So that would be 8 to the 1/3 and x to the 6 to the 1/3, but wait a minute. 6 times a third is 6/3, and 6/3 is the same thing as 2. And what's 8 to the 1/3 power? Just 2? So both ways, same answer, whichever way you prefer. Question on this. Okay. I'm going to touch on a topic that, I do this all the time, that you will see little bits of, and sometimes you'll see it, sometimes you won't, but you need to know when it's proper so that if you see it on an ACT, SAT, you don't miss it. Okay? So this problem right here says the 4th root of f to the 8 and g to the 4. Simplifying it is really easy, but there's an extra piece that you're going to need to know when we go to do problems in a sec. So how many times, this is what I'm asking myself, how many times does this 4 go into this 8? 2. Good. How many times does this 4 go into this 4? Once. And there's no leftovers. We're going to do a problem with the remainder in a sec. Everybody good so far? Okay, now, here's my problem. Isn't this an even index? Whenever this is even, that means my domain is restricted. My values have to be greater than or equal to 0. There's a math symbol that does that for us. That's that absolute value bar. The absolute value bar makes a value positive. So when you restricted your domain on that frame before and it said x had to be greater than or equal to 0, because your index was even, we need to do this to the g, because we don't know the value of g. So we're going to throw bars around him. And now it's protected, and we know it's going to be positive. Why did I not have to put it around the f squared? When you square something, it's automatically positive. So it's already got protection. Okay? Question on that? Good. Okay, I did that. That's in your book. Okay, so I'm going to break you guys up in a sec. But I want to talk through letter A, and I also am going to talk through letter B, because what I just found out in the last 2 classes was a lot of people messed up on that one. So I want to make sure you're good to go on that instead of staring at it, or in one class they were kind of arguing over what to do. So let's start with A, because that's really easy, I think. It's a nice square root. So I'm going to work it through in my blue. What is the square root of 16? Ella, 4. Okay. Now it's taken for granted that your little index there is a 2. So we have an x to the 6 now for the second part. How many times does 2 go into 6? 3. Okay, one little thing that I need. Is this even? Is 2 even? So what do I need to put around my variable? Absolute value bars. I don't like the way they wrote the answer. You would rarely see it written like that in any other resource. So there we go. Done. Okay. Now the next one. The negative's on the outside. That's the only place it could be. It's the 8 that was messing people up, and then the v cubed that were messing other people up. We need to break up 8. This is what I was thinking I was doing before. Square root of 8. So do you remember before we said square root of 8 is like square root of 4 times 2. And then you guys were kind enough to tell me that that meant let me leave room to write everything. That would be a 2 and a root 2. Do you remember that from before? Everybody good with that, or do I need to write it out and do the steps again? Anybody? Tyler, you good or no? Okay. Now, here comes the v to the 3. You're doing long division in your head, but easy long division. There's a little index of a 2 right there. How many times does 2 go into 3? Once. Okay, so this is what I'm saying. How many times did 2 go into 3? And you said once. And you put a 2 here. This is you thinking. And then what's left over? 1. So that's the exponent that's left over, right? So you've got a v to the 1 left over on the inside, just like you had a 2 left over on the inside. And then there's one thing left I have to do. What do you think? Absolute value bars. Awesome. Thank you. Now, please don't ever put the bars around the constant. You know the value of the number. So that's not an unknown. So you don't put bars around it because we already know it. It's the unknowns that we're protecting. So what I need right now is I'm going to divvy these out. So I need you guys to do C, D, E, F, G, H, and then I'll let you guys do C. Okay? C. I think, oh, wait, did I go C, D? You guys are D. You mean like the number that would be here? Index. Good. Anybody still working on their problem? Anyone? Okay. So group C, you want to share out. There's 2 group C's. So either group C, share out. What do you think? Square root of? Perfect, perfect. So f squared, and it doesn't matter with these guys which one you put first. So the f squared, the d with the bars around it, and square root of d left over inside. Perfect. Did you guys get that also? Okay. Does anybody need me to chat through what they did? Okay. Next, choose D. Choose D. Okay, you guys are D? Perfect. H squared, J cubed, the bars around the J because we had an even index, so we had to protect the odd power to make sure that it is a positive. Everybody good so far? Okay. Who is E? Who is E? Which way did I go? Okay. Good, good. So final answer is 5, b to the 4th, and bars around the a and the c to the 5th. Perfect. Question. Okay, if by accident you put the b to the 4 inside the bars as well, that's okay. It's just like double protection. The fourth power is already going to make it positive, and then the bars are making it positive again. Okay, who's got F? Okay, what did we get?
We got 3x to the first y is the fourth, and then square root of x to the 1, and then we put absolute value bars of x.
Okay, so I think I heard this. So you got the 3, which was perfect. You got the x, and you got a y cubed. I think that's what you meant to say. And then you had the x left over inside, so the fourth root of x, and you had to have bars around both the variables. Perfect. Question on that? Okay, who's got G? G. These actually were the easy ones. Who's got G? Was that you guys? Wait, say it again. Is it like? Okay, no square root. You're going to be getting rid of the radical. Anybody want to help them? What do you think? You guys are going to be mad at yourself when you see how easy it is. How many times does 3 go into 9? Okay. So it's a quantity. Leave it alone. Don't touch it. Don't do anything to it. 3 went into 9 3 times. X plus 3 cubed. Okay, so my group H, what do you think? Perfect, perfect. X plus 3. And absolute value bars because we need to protect. Okay, question, yes ma'am. Okay, so who wants to answer? It's a really good question. Why did I need absolute value bars on H but not on G? Go ahead. Well, because this one was a square root even, and what kind was this? Odd. So you never need it. When the index is odd, you never need the bars. Good question. Okay. So I'm going to conclude in a sec, but I wanted to show you some stuff. These are off my study guide. So you need to go back now and start spending time going through all these that I'm applying to make sure you're good to go with these so you can start asking me questions. Okay? Good job as always.